Okay. My name is Jim Entz. I am a professor of art here at Porterville College and the coordinator to the Chap program, which is the Cultural Historical Awareness program. What we do, first of all, it was organized in 2002, so it's been 20 years that it has been in existence. But what we do is enhance awareness on campus and in the community for important aspects of our culture to which our community may previously have had little or no exposure. So each year, members of the Chap, that's faculty, staff, students, etc., choose a theme, and also members of the community, for the events. This year's theme is the Anthropocene. Interestingly, this talk is very, very pertinent to that, as you'll see. Faculty are encouraged to integrate the theme into their courses and to encourage student participation in the events. These events, guest speakers, panel discussions, exhibitions, concerts, etc., are organized throughout the year. They are free and open to the public, so let people know that. We also give out evidence of attendance or extra credit tickets to students, and if that's what you would like, either I or somebody will be by the door here after the talk, and we'll hand these out, one each. So, also, if you would please take a moment to silence your cell phones. I didn't have mine with me, so I can't demonstrate that, but I think you guys have it down, right? Well, our speaker, Richard Goode, Professor Emeritus of Physical and Earth Sciences, is an area native and a product of Porterville schools, including Porterville College. He has a BS in physics from California State University, Bakersfield, and an MS in geoscience from Mississippi State University. He holds California state teaching credentials in physical science, mathematics, and multiple subjects. Professor Goode retired in May of 2021 after teaching physical science, geology, and earth science at Porterville College for the past 22 years. He's a member of the advisory board for the environmental science pathway at Wenatchee High School and is the astronomy consultant for SciCon and Circle J Norris Ranch. He and his wife Georgia enjoy scuba diving and traveling to as many dive spots as possible. I was just a moment ago talking to him about something in the spring, and he said, well, I'll be underwater at that point. Well, here he is, Richard Goode.
Thank you. I thought I knew this subject fairly well, familiar with most of it, but with anything as you research, you tend to go down those rabbit holes where you get lost and keep wandering and wandering and wandering. Hopefully this won't be as depressing as I think it is. The Anthropocene, it is not an official unit of time. And there we go. Yet. It is an informal, I'm going to drive these camera kids crazy. It's an informal term that we use to apply to the current age. Most scientists are using it as if we were currently in the Anthropocene. It's used by a wide array of disciplines to denote the time in which man has become a dominant force on this planet. More and more and more, it seems that we have moved from being subject to nature being subject to us. The Anthropocene could become a formal unit of time if added to the geologic timescale, or it could just be anthropological or archaeological. For example, the Pleistocene in geologic time and the Paleolithic in anthropological match very closely. And so it doesn't necessarily have to be a physical marker in the geologic timescale. But for it to be a marker in the geologic timescale, there has to be some very distinct criteria that we can locate it anywhere in the world. And stratigraphy is the branch of science, of geology, that will make that determination. there is the International Commission on Stratigraphy who will make that decision. And in case you don't know what Anthropocene means, anthro is man, scene is recent. So recent man. The term Anthropocene has been used for a while. It was first applied to geologic concepts in 1873, in which an Italian geologist thought that we should be looking at something called the Anthropozoic, in which man has made a dominant impact on the planet. The actual term Anthropocene started around the 70s. The Russians used this as an official marker of time already. It was in 2000 in which it became a very prominent in use, and since then we've been using it quite a bit. A lot of authors in scientific papers are just assuming we already are in the Anthropocene. Geologic time. Deep time, 4.6 billion years of Earth's history. The Grand Canyon is a good example of this. You can see the layering in the Grand Canyon. The science of stratigraphy is based upon how those layers are oriented and how they fit into the scheme of things. We classify the history of the Earth in this way, in basic segments. It started out as a four-tiered system: primary, secondary, tertiary, and quaternary. As we learned more and more about the history of the Earth, the divisions became more distinct, and we were able to delineate different stages of the Earth based on fossils, prehistoric life, major geological events, and we were able to piece together. The quaternary is what we are in now, and that is the only epoch that still is in common use. Stratigraphy works based on the principles of Nikolai Steno, who came up with this. He was a priest in Italy, and he was very interested by fossils in the geologic record. And so he came up with these principles of stratigraphy that are very common in use today. Superposition, oldest on the bottom, youngest on top. Horizontality, the layers are deposited horizontally in sedimentary conditions. There's lateral continuity. This layer could be identified in multiple places around the Earth. Cross-cutting relationships, if one structure cuts across another structure, that structure must be younger. And then some other ones we've added since then: inclusion, if something is included, it must be younger. Biological succession, the history of life on this Earth. Simple creatures give way to more complex creatures in the time scale. And then unconformities, how we can account for missing gaps in the time. These things all help us put things in order. It was then James Hutton in England who came up with the idea of uniformitarianism, where geological and biological processes happen in a uniform fashion through time. That doesn't mean they always happen at the same rate. Obviously, there are short-term things like floods in some areas, droughts in other areas, but those things happen worldwide at various times, and we can track those. Currently, we are in the Maghalian age of the Holocene epoch, Quaternary period, Cenozoic era, Phanerozoic eon, in case you need to know your address in time. The International Chronostratigraphic Chart. There will be a quiz on this later. This is the one that is come up with by the International Commission on Stratigraphy. It is adjusted periodically. Annually it's reviewed. In fact, after 20 years of debate, the Holocene beginning has been moved back about 2 million years to adjust for a better marker in the geologic record. That's the one that's international. This is the one that the Geological Society of America puts out. It has more information for our perspective. You can see that there are those lines in there that are black and white. Those are magnetic reversals, and we can use those to geologically mark changes in time. For me and my classes, when I teach this is the one I use. It's a little bit more succinct, and it covers the major portions of what we really want people to know. Each line dividing one time period from another time period denotes something has changed on Earth. The longer the line, the more dramatic the change. The most dramatic change that we're familiar with is the Chicxulub impact that denotes the transition from the Mesozoic to the Cenozoic, in which 65% of all the species on the planet went extinct. We know that as the end of the dinosaurs. That one is kind of obvious, but if we go back in time and look, the difference between the Permian and the Mesozoic also marks a mass extinction. That's when we see 90% of all species going extinct. With an extinction comes another major growth of life, and so these divisions will generally be marked by the end of a fossil. We don't see ammonites in the record anymore, or the beginning of another type of fossil that we see. The times on the side represent the beginning of that time period. So the Holocene began actually 11,700 years ago with the end of the last ice age. We are now in an interglacial period, and another ice age should normally be coming. I say should normally be coming. For it to become a marker in the geologic record, a golden spike, a global boundary, stratotype, section, and point must be marked in the geologic record. For example, at the end of the Mesozoic, the marker is the iridium layer that's in the geologic record, in the sedimentary record, that indicates when the asteroid hit and deposited iridium pretty much all around the Earth. A second possibility would be a global standard stratigraphic age, a specific date, July 16th, 1945. Anybody have a guess as to why that might be a good marker in the geologic record? What's that?
Detonation of the nuclear weapon.
That is the date of the Trinity test in New Mexico that signaled the beginning of the atomic age. And so that is something that we could just set a date and not worry about finding something in the geologic record. As a geologist, I don't know that I like that. But that's just personal. These are the some, not all, of the conditions that are necessary for a golden spike to be marked. It has to have a definite lower boundary. There should be multiple markers in the record that we can find. It should have minerals that can be radiometrically dated using potassium argon, uranium lead, something along those lines. We're not, carbon-14 probably would not be a good one at this point in time, simply because it's all of these are too new for this to be used. It must be global, and we can correlate it in outcrops of various places, the United States, Europe, Australia. We should be able to mark all these. It has to be adequate thickness so it can be sampled repeatedly. People have to have access to it. And it should be unaffected by weather, climate, tectonic events, those types of things. These are currently where all the golden spikes are found in the world, marking the transitions between major time groups. That's not to say that that's the only place that can find them, but this is the standard, if you will. This is the point where it is well marked, and other places have to match that. The one in Greenland marks the beginning of the Holocene in a deep ice core, the beginning of the epoch we're currently in. This is the most famous one. This is in Tunisia. I forgot where it was. This is the boundary between the Cretaceous and the Paleogene, the end of the dinosaurs, 66 million years ago. Major extinction, dinosaurs went extinct, ammonites went extinct, and paved the way for mammals to become the dominant species on the planet. So for your existence, you should thank an asteroid. Which, I don't know if you read up in the news, where NASA just shot a spacecraft, the DART spacecraft, at an asteroid and changed its orbit. Finally, after 66 million years, the dinosaurs have been avenged. We shot back. And the jokes don't get any better, asked by students. The boundary, the golden spike for the Holocene is in Greenland. It marks the end of the last ice age, and we have various isotopes that are sealed in the ice, because as the ice formed, it trapped atmosphere, and the atmosphere from that time can tell us a lot about what was going on, and so it's just a marker in the ice core. This one also worries me as a golden spike, simply because we're losing ice at such a rapid pace that this record may be gone in a few years, few decades. So, Earth processes have always varied over time. Carbon dioxide, methane levels have been higher in the past, lower in the past. Planet's been warmer today. There have been periods of time when the planet has been completely ice-free. And there are times in which the planet has been in depths of an ice age. So why an Anthropocene? Has man become the driving process of physical and biological change on this planet? When you look at it, man has, well, carbon dioxide gets all the press. Carbon dioxide, too many carbon dioxide emissions. The Earth is warming. Carbon dioxide is at a higher rate than we've seen in a long time. But man, as an entity on this planet, has overtaken so many of the natural biological and geological processes. For example, we've altered the carbon cycle, the nitrogen cycle, the diurnal cycle, the hydrologic cycle, weathering and erosion. Our actions have altered all those natural processes. Man moves more sediment in mining and construction than all of the rivers on the planet annually. We are the major force of movement of materials. Okay? The acidity of the oceans is climbing because of the amount of carbon dioxide in the atmosphere. The pH in the oceans has dropped 0.1 over the last 100 years, and it's rapidly approaching the level it was at the end of the Permian, when 90% of all the species went extinct. This is the one aspect of climate change that worries me the most, is when the oceans crash, the system crashes, and life on this earth will become untenable for nearly 7 billion people. So, this is the average temperatures over the last 11,700 years. This is showing what has happened since the end of the last ice age. This is the Holocene's temperature markers. And it's really kind of obvious that over the last 4,000 years or so, we were heading into another ice age. We should be entering into another ice age. However, our actions on this planet have pretty much prevented that. You can see the average temperatures, the 1850 to 1990 average line, the last 2000 year line is the next one up, the last 10,000 year average, and then our current temperatures today. So we have, over the course of the last 2,000 years at least, slowed the rate, and we're seeing a rapid change in temperatures. Carbon dioxide. Carbon dioxide, as of the last available data, is 414.72 parts per million. It has never been higher than 300 parts per million in the last 800,000 years. And you can see it fluctuates with the glacial periods. It hasn't been above 400 parts per million for the last 3 million years. And so we're rapidly outpacing what the Earth can handle. Carbon dioxide and temperature measurements match very closely. And it doesn't always follow this way, but over the last 400,000 years, you can see that it has associated with it. The diurnal cycle. This is the Earth at night. We produce so much light on this planet that we've completely changed migratory habits. We have changed the day-night cycle for so many of us. Your cell phones at night, you have trouble sleeping because you're using your cell phone up until the time you go to bed. We have completely disrupted that, and we've altered the migratory habits of lots of different creatures. Don't know if you ever think about noise pollution, but I came across this one in one of my rabbit holes. This represents the sound levels in the ocean at the frequencies that most cetaceans use to communicate with each other. Whales, dolphins, that sort of thing. The coloration that you see there amounts to the decibel level. On average, between North America and Europe, the average decibel level in the ocean, it would be equivalent of us in here trying to do this with a leaf blower or a lawnmower in the room with us. So imagine trying to have a conversation with a lawnmower back over there running, mowing the carpet. That's what cetaceans in the Atlantic deal with. And you can also see on the second graph down on the right side, that happens to correlate very nicely with shipping patterns. So this is all artificially induced. So the big question is, when did the Anthropocene begin? Nobody in the conversation doubts that the Anthropocene has begun. Now the argument is, when do we find a significant marker in the geologic record? The two most often discussed is 1610 and 1964. Seemed kind of arbitrary, but 1610 is the date that they talk about for the collision of the New World and the Old World, in which we now can see lots of changes between migration to the New World and the migration of crops and things to the Old World. Other dates fit in here very nicely, and we can find some different events that we could work. The megafauna extinction, the extinction of mammoths and stuff around the world. There is really no potential golden spike, and it's not synchronous around the planet. It happens at different times in different places. When man arrived on this continent, the megafauna went extinct 10,000 years ago-ish. But woolly mammoths were still alive 3,000 years ago in remote parts of the world. And so it's not something that we can deal with. The origin of farming, that's a good one. That's when we really started to alter our culture and the earth around us. However, that's not uniform around the world. Farming started in different places and different areas. Extensive farming. Rice production. With rice production, we start to see a rise in methane in the atmosphere. And so that one, maybe we could denote that to some time in the past, 5,020 years before today. Anthropogenic soils, where our actions have actually changed the nature of soils around the world. But again, it's not really easy to find a stratigraphic marker that's uniform. Ones that are easier are more recent. The Old World, New World collision, 1610. There is a drop of about 7 ppm very rapidly in the geologic record. This is tied to the deaths of nearly 50 million Americans in North and South America, the natives, when disease was brought from the New World to the Old World. The Industrial Revolution, that one is something that most people point at, but once again, it's not uniform around the world. It started in Europe and we can find that coal ash layer in the geologic record in Europe, but then it happened later in North America, and it happened later in other places. Nuclear weapons detonations from 1945 to present. The 1964 date ties very nicely with the peak of radionuclides in the soil. And so that's a marker that we can find everywhere. And the last one, 1950 to present, trash, garbage, all kinds of industrial chemicals. The sulfur hexafluoride has been found in glacial ice, and that might be a good one. So these later ones seem to work better because we can find geologic markers. That circle there denotes the 7 parts per million dip of carbon dioxide that they have tied to the death of 50 million Native Americans. What happened when they died? Farming dropped dramatically in the New World. Forests regenerated, pulled much more carbon dioxide out of the atmosphere. But there's some problems with that because it doesn't match exactly with the death of Native Americans. And so there's some problems with it. But that is definitely recognizable in glacial ice. With the exchange of lots of different things between the New World and the Old World, New World crops going to the Old World, the pollen can be found universally in the Americas and in Europe, so that will work. The movement of other things from the Old World to the New World. Most significantly are those 3 at the bottom, smallpox, measles, and typhus, along with other diseases that hastened the death of so many native peoples in the New World. This is something that we can mark. This is something that can be found, and it has multiple markers. It has the pollen from these crops. It has the CO2 drop. So those types of things. This one works pretty well. My favorite is 1950. 1950 is the beginning of the Great Acceleration, in which so many things on this planet are beginning to change so rapidly. At the end of World War II, there was a lot of rebuilding, a lot of industry, and so we see this great acceleration. These are various things that were going on at the time. We can see the socioeconomic trends on one side, the Earth system trends on the other side, and that's a really nice graph. I like this, but yesterday I sat down and thought, it doesn't tell the story. This does. This shows how those things are all interrelated. You can see how many lines are heading towards carbon dioxide in the Earth system trends. You can see how many things are pointing towards terrestrial biosphere degradation. And almost every economic arrow, or almost every economic trend, eventually leads to some change in the Earth system. And so I like the 1950 marker because that really tends to show when things are rapidly changing around the globe. But I personally think I've found not only the golden spike, but the smoking gun. McDonald's restaurants. That right there to me says it all. I just find it very interesting that somebody thought to put that in this slide. One example, typical example, is our hyper-consumerism, our hyper-consumption of resources. Each one of you is individually responsible for tons of effects on this planet. You individually use tons of sand every year. Cinder blocks. You go into classrooms, buildings that you work in, roads that you drive on. You are personally responsible for all of that consumption. But one big one is our dependence on domesticated animals. We have turned from simple farms into mega farms. The best article I found on the Anthropocene as a marker is Gallus domesticus. We consume 60 billion chickens a year as a species. All those chicken bones have to wind up someplace. Could be a marker for the Anthropocene, chicken bones. They even suggest we should genetically modify our chickens even further than they are now, to where their bones are turned pink or purple or something like that, and when we come across that marker, we know we're in the Anthropocene. And chickens today have no resemblance to chickens 300 years ago, or even 200 years ago. They're bred for consumption, not for anything else, and so we have that. Right now on this planet, there's roughly 21 billion chickens at any given time. So, I kind of like that. What can we expect in the future from our hyper-consumerism? Lots of fun things. Sea level rise, higher temperatures. You thought this summer was hot. Just wait. Longer droughts, fire seasons, extreme flood events. Yeah, the list goes on and on and on and on. This is the depressing part. We're rapidly approaching tipping points, which will set up feedback loops, which means it's going to be much more difficult to stop what's happening. That the Earth system will take over because of what we're doing, and it will just go on and on and on and feed back on itself. We can see all the things that are going to happen, but just to point out some interesting things. Sea level rise. You can see that sea level rise is accelerating. As ice melts and the expansion of the oceans and more water in the oceans occurs, we're going to see much more rapid. We've gone from 0.6 millimeters per year to 4.4 millimeters per year, and right now it's almost 10 inches that the sea level is higher than it was in 1900. If sea level rise continues and we lose the ice at the poles and on Greenland and Antarctica, this will be what the world will look like. But I just read an article that this is optimistic. So for those of you who want to know where to buy land in North America, you can take a look and see how San Francisco Bay now comes all the way down towards Bakersfield. The Gulf of Mexico goes all the way up into Tennessee. We lose all of Florida. We lose the entire eastern seaboard up to the Appalachians. New Orleans is gone. This, in the most pessimistic sense, by 2200. In the most optimistic sense, it will be 2500, the year that this will occur. At the current rate, we're accelerating. Temperature trends. At the point right now, temperatures are rising 1 degree per decade. So, over time, we're going to see temperatures. By the end of this century, Porterville temperatures in the summer will be 8 degrees higher than they are now. So say goodbye to those 114 degree days and hello to the 122 degree days. Heavier rains, droughts, all of these things are increasing. Oddly enough, even though California is going to be much drier than it is today, this last year was the driest year in 128 years. Future years will be drier. We're going to have more mass flooding events. Because as water becomes more scarce, the land subsides, it can't absorb water as readily, and so we're going to see rains where instead of 3 inches of rain over the course of a month, we might see 3 inches of rain in 24 hours. And that water's got to go someplace. Category 4 and 5 hurricanes. Those are increasing. As the ocean warms, we're going to see more of those. Hurricane Ian in Florida is going to become much more normal to the Gulf and the eastern seaboard. Acres burned by wildfires. We're going to see more and more humongous fires than we've seen in the past. And the fires of 2020, California has had lots of carbon offsets where we've reduced, in the last 20 years, we have reduced the amount of carbon we put into the atmosphere by 70 million metric tons. The fires of 2020 in California produced 140 metric tons of carbon dioxide. So, a question?
No, I was just saying, oops.
Oops, yeah. Oopsie. Areas of high fire risk, don't live in the brown areas, okay? Iowa seems to be a pretty good spot if you want to avoid wildfires. But then you got tornadoes. You know, life's full of little trade-offs. Water supplies are going to continue to decline. As temperatures rise, water is going to become more and more scarce. You can see where no climate effects, we already have issues with water. You can see Kern County is really impacted, but as we add climate change, we're going to see less water available. In addition, as the temperatures rise, we're going to see more interesting diseases. I anticipate that by the middle of this century, we can expect multiple cases of malaria and yellow fever in places like South Florida, Louisiana. As the earth warms, those diseases migrate north. We didn't have West Nile virus in this area for the longest time because the mosquitoes could not weather over the winter. They couldn't survive here. Now they're here, and West Nile virus is becoming more and more evident, and it will get worse. We'll have more and more of those types of pandemics. Whether or not the Anthropocene becomes a formal unit of time, we as a species have really screwed it up. We are altering Earth at a rate that hasn't been seen on this planet since 66 million years ago when an asteroid altered Earth within 24 hours. We are doing it, we may even surpass that. We're number 2, we've got to try harder. We are cramming hundreds of thousands of years of biological and physical change into centuries. And it's just going to get worse because it's accelerating at a higher and higher rate. I think it's safe to assume that whether it's a geologic time marker or an anthropologic time marker, it's very evident that we are in the Anthropocene. Thank you. Questions? Faster than I thought. Anne-Marie.
Are you going to make the PowerPoint available?
I'm sorry?
Are you going to make the
Are you going
PowerPoint
to make the
available?
PowerPoint available somewhere?
I think that this whole thing is being taped and will be online in the Chap area, and the PowerPoint will be there. I can make it available to anybody who wants it, though.
I was also wondering way back on those golden spikes. It looked like a couple of them were close to the California area. What golden spikes do we have here? Are you close to us?
To be honest, I didn't look to see which ones were close to here.
Two in the west, really.
I'm trying to think which ones those would be appropriate. I don't know. I was concerned more with the transition to the Holocene that we're in now, and the big one that everybody knew about. Not that everybody remembers the impact that killed the dinosaurs. Sorry, I didn't mean to imply anybody's that old.
I'm kind of surprised you didn't put a dot at the Yucatan Peninsula on this slide.
The Yucatan Peninsula is not where the Golden Spike is. That's where the impact occurred, but the Golden Spike is actually in Tunisia. That's where the iridium layer is best identified.
Really?
Yeah.
I hate to admit this, where's Tunisia?
Tunisia is up there in North Africa.
Why would Did it like arc like the majority of the iridium?
It was a 6-mile wide, 10-kilometer wide asteroid that when it struck, it was penetrating the crust while its behind was still in space. And so that impact immediately sent tons of material into the atmosphere. In fact, the ejecta plume went up so high that it went beyond Earth's gravity. Possibly, well, there are probably remains, bone fragments and things of dinosaurs on the moon and on Mars from that event, that ejecta. It covered the Earth in a cloud, the nuclear winter scenario, blocking sunlight for at least 2 years. The peak, central peak in the middle of that crater temporarily would have been taller than Mount Everest. And the shock wave going out would have spread material. The tsunami would have been horrendous. The material, it was a global event. There was no place. There would have been massive fires in Siberia because of the hot material falling back. 95% of the forests were consumed by fires in a matter of a week. So
what happened in Tunisia exactly?
that just happens to be where it's the most undisturbed. The layer fits all those requirements of the golden spike. It's easily sampled. People can continue to date that sample over and over, access it. So it's just a convenient location.
Oh, it's not where the most iridium.
It's the one that fits the golden spike criteria the best. It's the one that is it fulfills these criteria plus a few others. Emery?
So, in correlating the rapidity of change with the sort of amount of damage, and you said it hasn't happened like this since
The Chicxulub impact 66 million years ago.
66 million. Has there been some study of like other times where we could correlate the rapidity of change going on? Well, particularly since humans entered the picture, the rapidity of change and how that affects cultures, like it's sort of, globally in terms of like,
Not uniformly. We can go back in the record and we can see the rapidity of change ever since, back going 3-4 billion years. We can see how things have changed in the rock record. It gets easier while we have fossils that we can check, and we can look at the fossils and we can determine, yes, this group of fossils ceased to exist and these new creatures arose. But then we also have to explain, why do we still have sharks who've been around on this planet for 250 million years? Why did alligators, toads, turtles, and some mammals survive the Chicxulub impact 66 million years ago? Change generally takes millennia to hundreds of millennia to occur, even millions of years. It took 250 million years for Pangea to break up to bring us to where we are today. But during that process, there's lots of indications that the asteroid doesn't necessarily need to happen to kill off the dinosaurs. We had massive volcanic eruptions in Siberia and India that covered hundreds of thousands of square miles, producing lots of sulfur dioxide, lots of carbon dioxide in the atmosphere. And that, with Pangea breaking up also, we had new ocean currents forming. We had lots of things going on that could have ended the dinosaurs without the impact. There's lots of things in that record that are sufficient to kill off the dinosaurs. The asteroid didn't help. It probably kicked it over the edge. It was such a dramatic event. But there have been other asteroid impacts in the past. This one just happened to be when we had an abundance of life on this planet that went extinct in one fell swoop. Other changes, you can see if we look at the temperatures for the last 11,700 years, you can see that we were warming after the last ice age. Then we began to cool to go into the next ice age. We should be seeing glaciers extending. We should begin to see the ice pack moving further south in Canada and Europe. We should see us heading back to 30,000 years ago when the Northwest was under 4 kilometers of ice over the next several thousand years. But we have stopped that from happening. And we are now, the big issue is we're compressing the changes so rapidly that the species can't adapt.
Another question. So I'm used to, when seeing documentaries or whatever on climate change and things like that. A lot of the time, the visuals that we get are things like ice, glaciers cracking up, or images of wildfires, various things like that. So in your presentation, we don't get those kinds of visuals. We get charts and maps and definitions, and those sorts of things. So I'm wondering if I believe that there's a way in which the medium is the message, and that given that now people are so overwhelmed by those images that are terrifying on a day-to-day basis, that they're impacting us, I think, in ways that probably increase all of those things, our consumption and everything else. So, has there been any attention to the idea of a sort of this kind of presentation being actually making the information more receivable? Not that it's not terrifying as well, but it does not actually have the same physical impacts on the body as watching animals dying and things like that. Is there a way in which that could help to communicate to at least those folks who understand charts and maps and things like that in a way?
I don't know. So many times the climate call to action for climate is those images. It's showing what the effects are, and not a scientific approach. And scientists have trouble expressing things to lay people often. We are comfortable with charts and graphs, and they make sense to us, but not often can we explain that down to a level where the average person really grasps what we're trying to say. In this case, I was just laying the groundwork for why we should consider that we are in the Anthropocene, and why I think 1950 is the appropriate date, not to call to action for climate change. The articles are out there. I read close to 100 different articles on climate change and the Anthropocene and the changes that anybody who wants to research it, it's readily available. I read more on this than I thought I was going to.
See, the fact that you could do that in scientific language and scientific images in a relatively brief amount of time, in a format that I think a lot of people could receive, is actually, I think, very helpful to the discussion, and very important. And I wish that science was, and bringing together a lot of the sciences in this format as well.
Yeah.
I think is a very valuable contribution to what we need to be understanding. I could see a lot more connections between things in this approach than when I'm overwhelmed by the emotions of the images, the arguments, and the debates. I think there is a certain clarity and irrefutability, unless you want to just discount all of science, and you're free to. But I really think that this approach needs to be taken more.
Well, thank you. I don't know how getting it out there is more. I'm not I don't have a large audience. I don't have hundreds of thousands of followers on social media. Or am I on social media? Anyways, it's not something that I expect we're going to see more of this, just simply because it is getting so drastic. And people who understand this are taking action, but that action also hits the pocketbook and is not easily accepted. These are hard choices. It's going to be expensive. people are going to die. The idea of no internal combustion engine cars being sold in California after 36 or something like that, that all will be electric. That's something that's hard for a lot of Californians to buy. But those types of choices are going to have to be made, or you can move to Tipton and have beachfront property. And I would want to live there.
Just the concept of acceleration. Just the concept of acceleration, internalized, gives a very powerful message that we need to slow down. Our processes, our consumption, and so I mean, I think that's, the acceleration thing is really important.
Yeah, it is, and because beef produces a lot of methane in the atmosphere, beef production is really harming the environment, beef consumption is. I eat more chicken. Saw where that got us. It's all this mega farming. And eventually when it crashes, it's going to get ugly. That's why I like the arrows on here. Just it can be a little bit more confusing, but it kind of gives you the visual on just how much everything relates to everything else. Yes?
Yes, so as you described, climate change is mostly not a direct result of us as individual humans, but it's rather the result of mostly industrial and agricultural uses of fuels and resources like water. So do you think that making this period of time, saying that it's our time, the Anthropocene, do you think that would make the population in general feel more responsible to the environment, or would that make them feel more entitled to do what they're doing?
It's a great question. I don't know. I would like to think that if people realize that what we have done to the environment collectively as a species, and even industrial processes and farming processes, we're still individually responsible for that because we drive cars, we wear clothes. And some things seem to be ridiculous. My wife has a fabric store over on Main Street, and cotton is grown here in the United States, and it's shipped to Asia to be made into fabric. It's then shipped to Indonesia to be printed, or China to be printed, and then it's shipped back to North America to be sold. And so the whole globalization of everything, nearly everything that we consume affects the environment. Even if you're eating organic and living as close to the land as you possibly can, there's still transportation costs involved. Yes, Fiji water is a great thing to support Fiji and it's purified, but the carbon offset to get it here, does it make sense? Does it make sense to buy water in California in the bottle that comes from California? My favorite photographs from the East Porterville water issue was a church group in Michigan, Detroit I think it was, sent a semi-truck full of bottled water to East Porterville, and that water was bottled in Fresno. So everything comes at a cost. I tell my students that there are short-term costs for long-term gain. There are long-term costs for short-term gains. So how we consume things, how we use energy, how we use water, how we use all of these things on here. Yes, we are responsible for carbon dioxide in the atmosphere just by breathing. So take every other breath. Doesn't seem practical. But like the big thing with carbon dioxide is our oceans are doing a fantastic job of absorbing carbon dioxide. But the same things that are absorbing carbon dioxide in the oceans, the carbon dioxide is going to kill. Because the plankton that are turning the carbon dioxide into calcareous shells, once that carbon dioxide gets to a point and the oceans are acidic, they can't make those shells anymore and they will rapidly die off. And once again, when the oceans crash, not if, when the oceans crash, so do we. Yes?
I'm more of a statement. I think your presentation is great, and to see this, I like this chart because you can actually see where you're going and stuff. And I know we're responsible for a lot of stuff, but when you're mentioning the cows, I mean, I'm a meat eater, I think chicken eater and everything. It's, when people see that and people make statements like that, you know, just to go to the point over here, there's people that always see it from a political view. Oh, you just don't like meat. You just are a hater of this. They don't see the facts. They bring in their own biases to the situation ahead of time, and whatever you put up there, they're gonna skew it or say, you know what, you predetermined this outcome. You already predetermined this outcome, so no matter what you believe in climate change, instead of coming, majority of people seeing it as honest, unbiased, this is the facts, and not just you saying it, but I can go to another presentation and almost have an identical presentation, but from somebody you have never even talked to or seen or went to school with. That should be enough for the average intelligent person without bringing those biases in. And I think until we get over those biases that we have as a nation, as a world, we're not going to solve any problem. It's going to go to where you say we're going to go. You know,
Science has become so politicized, and that is a real major problem in our country and other countries as well. The anti-vaccination movement, the anti-COVID movement, the don't wear a mask idea, the climate change is a hoax. If the Earth is getting warmer, why are we having massive ice storms in the Northeast? But as we're altering the processes, the Earth has to adjust, and things are going to become more and more erratic. And so all of those things are perfectly normal processes that the Earth would see. But until we can break through that politicalization, it's not going to change.
No, yes, just very quickly, I just wanted to say that, you know, when the gentleman and you were talking about, say, meat production and agricultural production, how that is responsible for a majority of the water use and a lot of the carbon emissions and the methane emissions. This issue it's always addressed in a way where it's up to you as a personal responsibility. Like, you know, don't eat meat or don't drive to work or anything like that. But the fact is that the developed world mostly, all those carbon emissions are not from individual people, but from companies and corporations that either process the meat or process textiles and consumer goods, and they're the main producers by far, and they create much more carbon than any normal human would. Because, you know, humans are just going to create carbon. Walking generates a certain amount of carbon, and so does breathing, like you said. But a lot of this shouldn't be just, in my view, personal responsibility. It should be pressuring our society to change. So instead of relying on industries that can pollute the atmosphere, you know, without consequence, is that we should really consider changing that system so that we can save our planet, instead of them just telling us for us to not drive to school or like that.
Those are good points, but the only reason they're producing what they're producing is because we're consuming what they're producing. And so individually, we still have a responsibility. We need to wean ourselves off fossil fuels. That, bottom line, that right there would be a major change. It's the fossil fuel manufacturing and consumption that heats our home, cools our home in the winter, in the summertime. It provides us transportation with our vehicles. It provides energy to power our electric cars. So until we can break the addiction to fossil fuels, we're really not going to see that much of a change. And individuals lobbying, supporting candidates who care about the environment, doing whatever we can as individuals. It still has to be individuals that start to change. And so I'm not saying that you're going to change everything overnight, but you, collectively with other people who think the way you do, will make a difference. And yes, if we all cut down beef use to once a week or once every 2 weeks, we would see a dramatic reduction in methane production in the United States. But getting people to make that decision is hard. I saw a hand over here. Yes?
Well, I just wanted to give a little shout out to California. We've seen a change because of people's use of plastic straws and utensils and urging, you're seeing this now every time you go through the drive-through, you have to ask for certain things. You have to ask for utensils, you have to ask for condiments that come in little plastic containers. So I think I just want to celebrate that as showing how just some influences from consumers and people who listen to them have made some small changes for that.
Well, in California, we're very environmentally conscious because we know our issues. And so those types of things were passed legislatively in California, and consumers didn't like it for the most part. I hear unending complaints about paper straws.
But they were listening to somebody.
Yeah, well, exactly. And that's one thing that we can do. We can support candidates for elected office that do want to reduce consumption, that do want to turn things around. Because as it's going right now, extinction for a lot of species, including us, is on the table. It's not going to get any better. It is going to get worse. And yes, we have to do it collectively. We can't do it as an individual. We can stop consuming. We can stop buying things that are already pre-made. We can start cooking our own food at home and living simply.
Just a brief comment. I agree with the gentlelady. It is a remarkable achievement. It's the bare minimum, but it's
something.
It's something, yes. A lot of this, consumer waste is generated by giving the consumers the product that, like plastic or paper, and then depending on us to recycle those materials, and even then the recycling process is not very efficient in the US. And I remember going to the grocery store and seeing like individually wrapped apples, like in plastic. And a lot of these things like carrots and potatoes and things like that will be in plastic bags, but they were grown in literal dirt. So it's those kind of wasteful uses of plastic. Because plastic is something we will have to use. It's very versatile and flexible and easy to make, and has changed the entirety of how we operate as humans. We depend on plastic. But I think especially cutting down on not giving consumers a product that is not biodegradable and it is hard to recycle is meaningful change already. That's just a statement,
Yeah, but there's the other. I mean, could we buy a head of lettuce and make a salad instead of buying pre-cut lettuce? Are we that lazy as a society? Yes, obviously, because it's available. The grab and go, prepackaged meals, and all that kind of stuff. It is very difficult to make hard choices at the grocery store when there are so many easy choices, and that's that consumerism that we've got, that hyper consumption of all kinds of things convenient, especially in this country. My sister in Europe still has groceries delivered every day because she doesn't go to the store. She's become a recluse because of COVID, but it's still, the ingredients are delivered every day and they prepare them. It's not like you have to, it's not the prepackaged stuff. So yeah, very good thoughts.
Yeah. Can we continue the conversation up here if you want to? I'm getting to the point where I think some students are thinking, I gotta go.
Oh, they don't want to leave. They love it.
I know, that's so true. But anyway, let's do that. I'll have these extra credit by that door there if you want that.